Welcome back. So, this is lecture 12 in this course on mathematical tools. The topic of this lecture is sine and cosine functions. This is the second lecture in trigonometric functions, and we are going to talk about the sine function and the cosine function. In the previous lecture, I introduced you to the idea of trigonometric functions using an example of a rotating ladder. Okay, and we saw that the height of the rotating end of the ladder divided by length of the ladder is a function of theta, and we call that function the sine function. Okay. So, just to recap, so let us say there is a ladder with fixed end O and a free end P, okay, and let us say you rotate this ladder in anti-clockwise direction. Let us say after some time the ladder reaches this position. Okay. So, this is the free end P, and let us say the angle it makes with this reference, okay, is let us say theta, and height of this rotating end P from this reference is y, length of the ladder is r, then y by r is actually sine function of theta, it is actually sine theta. Okay. And we also saw how this function behaves. Okay. So, I will draw the different positions of the rotating point P and its corresponding with the value of the function corresponding to that position, right. So, I will first draw a graph. Okay. Now, this is xy plane. On y axis you have actually y by r, that is the height of point P divided by length of the ladder. This is theta on x axis. Here the value of theta is 0, here the value is pi by 2. Okay, let me let's say 0, pi by 2, pi, 3 pi by 2, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, 7 pi by 2 and 4 pi, like this. On this direction, let us say minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay. Let us take the ladder. We will represent the ladder like this. So, let us say this is this is the reference horizontal plane and this is the ladder. So, at this position, at this time, at this point, the ladder is actually horizontal. So, it does not make any angle with the ground. So, this here is point P. So, the height of the ladder with respect to point P remains 0. So, the value of the function is 0 here, and let us at this position the ladder becomes vertical. Okay. So, height is r as well as the length of the ladder is r. So, the value of function becomes 1. In these positions here, the ladder is actually has some height from the ground, okay, and it is less than 1 divided by length of the ladder, it is less than 1. So, it keeps on increasing like this, okay, and you can actually visualize the ladder is always rotating as the angle is increasing. Okay. So, it is started here. So, at this point the height of the point P was 0 and started increasing. Okay. So, this is some angle between 0 and pi by 2. At pi by 2 the height becomes exactly r, equal to length of the ladder. At this point at pi by 2, at pi the height again becomes 0. At this angle 3 pi by 2 height becomes minus r, okay, and again it at 360-degree height again becomes 0. Yes, this is how the ladder is rotating. So, this value of the y by r, basically value of the function, keeps on increasing, and would again become 0 at pi and keep on decreasing and would become minus r at 3 pi by 2. Okay, and then it would become 0 at 2 pi, will again starts increasing and will become r at 5 pi by 2, would become 0 again at 3 pi, would become some negative value at 7 pi by 2, would become 0 again at 4 pi. Similarly, in this direction, it becomes negative at minus pi by 2, becomes 0 at minus pi, becomes positive 1 at minus 3 pi by 2, and so on. Okay. So, this point is actually 1 and this is actually minus 1. So, the value of function always remains between minus 1 and plus 1. Okay. So, that is the one property that we know of sine function. So, value of sine theta is from minus 1 to 1. What are the other properties that we can see here? That function is periodic. So, the function is started increasing here, then decreasing, and then reached back here, and from this point 2 pi, the function has exactly same behavior. Okay, so if you see this graph between this point 0 to 2 pi and then 2 pi to 4 pi, okay, in this slab and this slab, the graph is exactly same. So, function is repeating itself within this domain of 2 pi. Okay. So, periodic function, okay, and it repeats after 2 pi. Okay. What else? Is the function symmetric around the y axis? No, not really. You can't say function is symmetric because as you are increasing values of theta in the positive direction, the value of the function is increasing, but in the negative direction, the value of function is decreasing. So, you can't say it is symmetric. Although, you can say that basically the same property is extending in the negative direction. So, such that the function was, because it was decreasing from pi by 2 to 0, it keeps on decreasing from 0 to minus pi by 2. Okay. So, this function is actually symmetric, but it is symmetric around, let us say, pi by 2. So, if you draw a line at pi by 2, okay, so y equals x equals to pi by 2, the function would be symmetric around that line. Okay. So, around this. Okay. What else? Now, theta can take any value, okay, from minus infinity to plus infinity. Okay. The only constraint is on codomain. Okay. So, that is your sine function. Now, the sine function gives you height of the rotating end p divided by length of the ladder. But what if we want to calculate the distance of the point P, okay, along this horizontal axis from the origin? Okay. So, let us say you want to calculate. So, when let us say this is the fixed end of the ladder and the ladder is rotating, this is point P. Okay. So far we have been calculating height of point P from the ground. Okay. This height y. Okay. But what if I want to calculate distance from this fixed end to this point? Okay. So, how far is point P from the origin along this horizontal plane? Okay. Let us call it x. So, what if you want to find x? Okay. What would be x? Let us think about x in the same way. So, when you begin, so when theta is 0, so let us rotate this, let us keep rotating it in anti-clockwise direction in exactly similar way. Okay. So, when theta was 0, okay, then basically this ladder was along this horizontal axis. So, what would be this distance x? from origin to point P along the horizontal axis, that distance would be exactly r. But when theta becomes pi by 2, the distance of point P from the origin along the horizontal axis in the horizontal dimension, it would be 0, because now origin and point P are exactly in same line. So, there is no distance between them along the horizontal axis. But when theta becomes, let us say, 3 pi by 2, not 3 pi by 2, sorry, let us say pi, then this distance becomes minus r. This goes in the opposite direction. At 3 pi by 2, this distance would become 0. At 2 pi, the distance becomes again r. So, this function behaves in this way. So, you can write x is a function of theta and r, and similar to what we did before, x is r into some function of theta, right. So, x by r can be said to have a function of theta, and that makes sense because when you take theta 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on, the value of x by r is actually 0. Sorry, not 0. At 0, the value is r divided by r, 1. Then it becomes 0 at pi by 2. Here it becomes minus 1, and 0 and 1. So, this is how the value of x by r repeats. So, you can write x by r is a function of theta. Now, it is a different kind of function. Let us try to draw its graph. So, how the value of x is changing, sorry, x by r is changing. So, at 0, the value of x by r is 1, and at 90 degree at pi by 2, let me write pi by 2 here, pi by 2, at pi by 2, it decreases and becomes 0, and at pi, it decreases even further and becomes negative at pi, and then it starts increasing and becomes 0 at 3 pi by 2, and then it becomes 1 again at 2 pi, and so on. So, this is how this particular function behaves, right, and would behave in a similar way in this direction. Okay. Now, this looks different from the sine function. Remember the sine function? So, in sine function, the value of the function is 0 at theta 0, and then it increases, then decreases, and so on. Although the curve looks similar, but the value of the function is 1 at 0, and it becomes 0 at pi by 2, and so on. Okay. So, x by r, you can say it is a different function of theta. Let us call it g of theta. Okay. It's also a function of theta, but it is a different function. This function g is called a cosine function. So, g is a cosine function. So, you can write x by r, which is basically base of the right angle triangle, divided by the hypotenuse, is actually a cosine function of theta. So, x by r is equals to cos theta. So, that is what we call cosine function in short. Okay, it is cos theta. Okay. So, this is how sine theta and cos theta works out, right. So, sine theta is perpendicular. So, if you take a right angle triangle, and let us say this is the angle theta between the hypotenuse and the base, okay. Let us say this is the right angle triangle, then y by r perpendicular divided by hypotenuse is actually sine theta, and x by r base divided by hypotenuse is actually cos theta. Okay. Even more, you can also derive what would be x by, what would be, let us say, y by x perpendicular divided by base. So, if you divide y by r by x by r, basically if you divide equation 1 by equation 2, you will get y by x equals to sine theta divided by cos theta, which is some other function, and that function is called tangent function, tan theta. We will talk about it more in the next lecture, but sorry, you can basically figure out what is this y by x, okay. So, which is tan theta. Okay. But let us take a look at sine theta and cos theta and relationship between them. Okay. So, what you have learned is that y by r is sine theta, x by r is cos theta, and this is your right angle triangle. Do you know some of properties of right angle triangle? If it is a right angle triangle, you might remember this, that perpendicular square plus base square plus perpendicular square and its square root would be actually your hypotenuse r. Okay, you might remember this property. That means x square plus y square is equals to actually r square. Okay. Okay. Can we write x and y in form of sine theta and cos theta? Yes, we can. X can be written as r cos theta. So, from this x can be written as r cos theta, y can be written as r sine theta. So, x is r cos theta. So, r cos theta square, y is r sine theta, r sine theta square equals to r square. Okay. So, this becomes r square into cos square theta. So, basically square of this function cos theta, and this is r square and sine square theta, square of this function sine theta, equals to r square. Now, if you take r square common, what you get is cos square theta plus sine square theta equals to r square. You can cancel out r square, and this gives you a very important identity, which is that r square theta plus cos square theta equals to 1. So, given a right angle triangle, given the same angle theta, sine square theta plus cos square theta is equals to 1. Okay, and it makes sense, you can test it. So, what if the angle is pi by 2? So, at pi by 2, what is the value of sine theta? 1. Okay, so you are basically taking 1 square, and what is the value of cos theta? 0. So, 1 square plus 1, 1 square plus 0, it would be basically 1. Okay, so it satisfies. What is the value of the function at, let us say, 0? So, at 0 sine theta is 0, but the value of cos theta becomes 1. So, it also becomes equal to 1. Okay, so this statement holds. Okay, you can also see this thing in the graphs. Okay, let us draw the graph of both sine theta and cos theta in a single graph. Let's say this is theta, x axis theta, 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay, this is how the graph of sine function looks like. Okay, and this is how the graph of cos function looks like. 1 at here, so on. Okay, like this. So, this is how sine theta, so this is cos theta, and the blue one is sine theta. Okay. Now, what happens is that sine square theta plus cos square theta has to be 1. Okay. So, that is why what you would see is that in both these functions, the codomain is from -1 to +1, right? And at any point, if you take the summation of their squares, it has to be 1. So, basically it would never exceed 1. So, at the points where cos theta reaches maximum, sine theta would reach its minimum. Okay. So, it is like that, or not minimum, or at least 0. Okay. So, at any point, let us say you take any line here, okay, here at this point, sine theta would have some value, cos theta would have some value, and the sum of their squares is actually 1. So this is how the cos theta and sin theta look like. Okay. So these are two important functions that we require in solving trigonometric problems. So using sin theta and cos theta, it has a lot of applications. So for example, you have seen some direct applications. The ladder is standing against a wall, and let's say you know the angle from the ground, then you can figure out at what height this end P would reach on the wall if you know the length of the ladder, right? So you can figure out this distance, this height y. Okay. It has applications in almost everything where you are dealing with right angle triangles. Okay. Now in dynamic functions, in dynamic systems, it has more interesting applications where, let's say, a system is changing periodically. Okay, so the state of the system is changing periodically. There you can use sine and cosine functions. Okay, so just to give you one more interesting property. So if, let's say, let's say I want to calculate cos theta plus pi by 2, what it would be? Cos theta plus pi by 2. Okay. So theta could be some angle. Let's say that angle is here. Let's say that angle is pi by 4. And if you add pi by 2 to this, okay, how much it would become? Basically, you are looking at here then. Okay. How much it would be? Well, this value would be same as cos theta. It has exactly same value at the other point. Not necessarily exactly the same value, but it would be related to cos theta, right? So because only thing you are doing is that you are observing the same function after a fixed interval. What if you do theta plus pi? Okay, so you observe, let's say, theta here, let's say theta is 0 degree, and you observe it after pi. So after pi here, the cos theta becomes what? So here cos theta is 0, here cos theta becomes 1. Okay. Similarly, if you observe it here first, pi by 4, it has some value, and if you observe it at pi by 4 plus pi, so basically 5 pi by 4, which would be here. Okay. So it is systematically related. We can figure out always. And if you, let's say, have cos theta plus 2 pi, okay, now because the function repeats itself after 2 pi, this would be same as cos theta. So after 2 pi, so at 0 you have this value of theta 1, and after 2 pi you would have again the value 1. So this is equal to cos theta. Okay. Similarly, you can do the same for sin theta. So if you add some period, some fixed interval to theta, so the resulting function would be systematically related to this function cos theta. Sometimes it could be equal to cos theta if you are repeating the interval of the function where the function repeats its value. Okay. All right, I will stop here. We will talk more about trigonometric functions. In the next lecture, I will introduce you to tan theta, okay, which is another interesting function, and we will discuss some trigonometric identities as well. Okay. All right, I will stop it. Thank you.